Hello, geometry students. Today we are doing lesson 2-6, which is proving geometric relationships. Now there's a couple parts in here because we're going to be talking about some different proofs, so I'm going to try to get this all in one lesson, but we may have to do a second lesson on this, so we'll see how it goes. All right, so one of the first theorems that we have in today's new material is the right angle congruence. And basically the right angle congruence just says all right angles are congruent. So if I tell you angle 1 or angle A is right, and then I tell you angle B is right, we can now make the conclusion that angle A is congruent to angle B. And why can we say that? So if this is our statement, why can we say that? And you can either say right angle congruence theorem, so right angle congruence theorem, or what I have a tendency to say is I just say this: all right angles congruent. So I don't care which reasoning you get, I just have a hard time coming up with this exact name, right angle congruence theorem, and my brain just always remembers that all right angles are congruent. So you can put either one of those down as your reason. All right, you may need to pause this video right now so that you can get this all in and then continue on as I'm going to continue on explaining. So actually, I'm going to do a little thing here. If I say angle 1 plus angle 2, or angle 1 and angle 2 are complementary, what does that mean? That means 1 plus 2 equals 90. And I tell you angle 2 and angle 5 are complementary. Is there anything that you can conclude now when we talk about angle 1 and 5? So if 1 plus 2 equals 90 and 2 plus 5 equals 90, what is going to have to absolutely positively be true about angle 1 and 5? So angle 1 and angle 5 are definitely going to have to be congruent. Okay, so that's what this theorem that I was just going to have you write down is called the congruent supplements theorem. If two angles are supplementary to the same angle, then they must be congruent. So 1 and 2 are supplementary, 2 and 3 are supplementary, making 1 and 3 must be congruent. And this is called the congruent supplement theorem. Okay, now we not only have that with supplement, so that equaling 180 degrees, but we also have it with the complements when those two angles are equaling 90 degrees. So this is called the congruent complement theorem. Now again, I have a hard time remembering that, so I have a tendency to write everything in green as my reason. So if two angles are complementary to same angle, then congruent. So I have a tendency to write two angles complementary to same angle, then congruent. So my brain has a hard time remembering the congruent complements actually name of that theorem. So I will sometimes write out the whole thing in green, just abbreviate it a little bit. So if you have a hard time remembering the full name, if you explain what the theorem is, then that will work for you too. All right, so in here, which pairs of angles are congruent? So just to make things a little bit easier on us not having to always use letters, I'm just going to put angle 1, 2, 3, and 4 in there. So which pairs of angles are congruent? Well, I think because those are both marked 50, we can say angle 1 and angle 3 right off the bat are congruent. Well, because this is a right angle, R is a straight angle, and because that is a straight angle, then that means that it's going to equal 180. So if this part over here is 90 degrees, then we know this is 90 degrees. So we can say angle MSP and angle PSR because they are both 90 degrees. Now, what about 1 plus 2? Aren't 1 plus 2 complementary? And 3 plus 4 complementary? And because 1 and 3 are congruent, isn't that going to make angle 2 and angle 4 to also be congruent? All right, find each angle measure. Well, we have a theorem that says that vertical angles are congruent. So we had a theorem. Oh, I think we skipped a slide here. So we have 2 more theorems in here that we didn't put in our notes. I skipped over it somehow. So we have the linear pair postulate, where you have linear pair, angle 1 and 2. So you have a straight angle formed by 2 adjacent angles because they share a common point, they share a common side, and they have no overlapping interior points. So 1 and 2 are adjacent angles, and they form a straight line, so we call that a linear pair. And then a linear pair is always going to be supplementary, so their sum's always going to equal 180. So that's called the linear pair postulate. If 2 angles form a linear pair, then they are supplementary. Okay, and we talked about this before, that vertical angles are congruent. Now, on to this next diagram here. So if we know angle 1 is 34 degrees, then by vertical angles, we also know that angle 3 must be 34 degrees. And then here we have 1 plus 2 makes a straight angle, so angle 1 plus angle 2 must equal 180. Now we can substitute this 34 in for the measure of angle 1 by using substitution. And now by subtracting 34 from both sides, we can get the measure of angle 2 to be, what's that, 46 degrees? How about 146 degrees? Wow, almost off there by a lot. So 146 degrees for the measure of angle 2. And angle 4 is vertical to that, so that is also going to be 146 degrees. All right, so now moving on. Okay, it looks like we have 2 lines here, and it looks like we have opposite angles, so it looks like 8x plus 7, these are vertical angles, must be equal to 9x minus 4. So it looks like I'm going to subtract 8x from both sides, and I'm going to add 4, so it looks like I get x to be 11. And then now we can set up, because this is going to be a vertical pair, 5y and 7y minus 34 are going to have to be equal because these angles form a vertical angle and they are congruent. So I'm going to subtract 5y and add 34. So I'm going to add 34 to both sides. And then I'm going to subtract 5y from both sides. I'm going to divide both sides by 2. And so I get y to be 17. So it looks like x is 11 and y is 17. All right, I think that brings us to the end of part 1. So I'm going to jump over here and see if we can get part 2 done in this same video. So it's still proving geometric relationships, but we're going to talk more about proofs in here. And what we have done so far is called a 2-column proof. But there are other ways to write proofs, and one is called a flowchart proof. That uses boxes and arrows, so you might take a box here and a box here, and these 2 ideas might come together and form a box, and then this flows into this box, and then we might go here. So this is what a flowchart is going to look like, and you put your statement inside, so your statement goes inside the box. And then your reason, or bubble, I should say, and then outside that bubble is going to be your reason. So the reason just goes right outside the bubble. A paragraph proof is just you writing the proof using sentences. So it just kind of runs on from one to the other. It's not one column and then the next. So we're just going to run through some different examples of those proofs here. So if you recall, we've got a right angle congruent, so all right angles are congruent. So here is what a flowchart proof would look like. So you can see that this given information, the statement, angle 1 and 2 are right angles, that's given, and you can see the given underneath it. Now you can see that that bubble has this arrow, so they're saying from this, we can now say what? Well, if they're right angles, the measure of angle 1 equals 90, and we can also say the measure of angle 2 equals 90. That's the definition of a right angle. So if you have a right angle, they equal 90 degrees. Well, now what do we have? 1 equals 90, 2 equals 90, they both equal 90. So by the transitive property, 1 is equal to 2. And then this is one of those things that is pretty nitpicky that I am not going to be particular about, but if you're doing any kind of proof in the book or online, they might throw some of these reasons in. So you see the only difference here is the measure of angle 1 equals, and then they took out the measure and they made it congruent. So that's called definition of congruent angles. And when they do that with segments, so AB is equal to CD, and the next one they say AB is congruent to CD. This would be definition of congruent segments. So they use this in segments and in angles. So this is a flow chart proof using bubbles and arrows and the reason underneath. All right, continuing on here. So we have these two theorems that we talked about earlier. So now here is the proof, and they write it to column. So given information, and then if they're supplementary, that means 1 plus 2 is 180, 3 plus 2 is 180. Well, now if they're both equal to 180, we can say they're equal to each other by transitive. Some people are going to call this substitution. Either one will work. And then we've got angle 1 equals angle 3, because what are we going to do? We're going to subtract those out. All right, continuing on. So here again, linear pair, vertical angles, the one I almost missed over there. Looks like we can't quite see that in there. So vertical angles in there. And so now they're going to write this one by a paragraph proof. And so they just use words and sentences to say the exact same thing. So here we go. Angle 5 and 6 are vertical angles formed by intersecting lines. As the diagram shows, so looking at this diagram, 5 and 6 form a linear pair, and 6 and 7 form a linear pair. So, by the linear pair postulate, 5 and 6 are supplementary, 6 and 7 are supplementary. Then we also had a theorem in there that says something about if they are supplementary to the same angle, then these angles must be congruent. So in 5 and 6 are supplementary, 6 and 7, then that, because they're both supplementary to 6, that conclusion is that 5 is congruent to 7. So you don't have to put all those extra words in there, but just explaining it. So this is what a paragraph does, is it kind of gives the reason and the statement all in the same one. All right, here's another flow chart. We wrote this one in notes yesterday when we were doing lesson 2-5. So in here, 1 and 3, so this would be given information. And then EBA 2 plus 3, so this is angle addition. And you can see that this arrow goes here, and this is a completely separate thought. There's no arrow between them because one's given, one came from the diagram. But these two thoughts are coming together to now have us be able to write this. So instead of having angle 3 in here, we're putting angle 1 in there. So that's called substitution. And then in here, what they did is they switched the order. And remember yesterday I said that we don't have to worry about that. If you didn't do that, it would be no big deal. And then we took a total separate thought again, 1 plus 2. So this is angle addition. But do you see this is a separate thought? There's no arrows coming to this. This is a separate thought that came from the diagram. Now taking this thought and this thought together, the two of these together can be combined. So they're both equal to 1 plus 2. So that means this must be equal to that by the transitive property. Okay, so people just write up. So if there's a separate thought coming out, then there's no arrow going into it. So this is a flow chart proof. All right, we wrote that one yesterday in our notes, so we don't have to do that again. And this last thing is just summarizing everything. So if you want, you could just freeze this and copy what you feel like you need to down. Most all of our proofs that we are going to be writing, especially on the chapter